Now we move on to question number 4. In this, we are given a set of probabilities and returns. Let's see the question. Suppose an investor is concerned about a business choice in which there are 3 prospects. Now we need to calculate the expected value of the uncertain investment. The expected value EV can be calculated here as EV equals to 0.4 into 100 plus 0.3 into 30 plus 0.3 minus 30, and this amounts to $40. Similarly, for the variance, which is equal to sigma square, we can calculate as sigma square is equals to 0.4 into 100 minus the mean, which is 40, whole square, plus 0.3 into 30 minus 40 whole square, plus 0.3 into minus 30 minus 40 whole square, and this comes to $2,940. In the next question, we see that we are an insurance agent who has to write a policy for the new client named Sam. His company, Society for Creative Alternatives to Mayonnaise, SCAM, which is working on a low-fat, low-cholesterol mayonnaise substitute for the sandwich condiment industry. Sam's scam seems like a very risky proposition to you. You have calculated his possible returns in the table as given as follows. The probability 0.999 is given a return of minus $1 million and a probability 0.001, and the expected payout is 1.0 billion if he succeeds and sells the formula. Now we find the expected return of his project and then the variance. Now expected return ER is equals to 0.999 into the expected payoff if you lose, plus 0.001 into the payoff that he'll get if he succeeds and sells the formula. Now expected return of this project is $1,000. Now we find the variance sigma square, that is equals to 0.999 into minus 1 million minus 1000, which is the mean, whole square, plus 0.001 into 1 billion minus 1000 whole square. $1 billion that is equals to 100,999,000,000 dollars. Now in the next question, we assume Sam is risk neutral. What is the most Sam is willing to pay for insurance? Sam is risk neutral, and because of this expected outcome is $1,000. Thus, Sam is unwilling to buy insurance as his expected outcome is much greater, and he will be willing to take the risk without paying for any insurance. Next, we figure out a situation. Suppose we find out that the Japanese are on the verge of introducing their own mayonnaise substitute next month. Sam does not know this and has turned down your final offer of $1,000 for the insurance. Assume that Sam tells you Scam is only 6 months away from perfecting its mayonnaise substitute. As you can see from the question, that we already know about the Japanese. So based on this information that we are given, what will our move be? Would we raise or lower our policy premium on any subsequent proposal to Sam? And based on this information that we are given, would Sam accept it? Let's see. The entry of Japanese lowers Sam's probability of a high payoff. Assuming that the $1 billion payoff gets reduced to 0.0 probability and the payoff is lowered to 0, then the expected outcome will be equals to 1 into minus 1 million plus 0 into 1 billion dollars. That will be equals to minus 1 million. Now in the next question, we are given a utility function of an individual named Natasha, which is UI equals to root 10i, and I represents annual income in thousands of dollars. Now we need to find out whether Natasha is risk loving, risk neutral, or risk averse. Let's explain. Natasha is risk averse. The reason being, let's assume that she has $10,000 and she is offered a gamble of $1,000. And this is a $1,000 gain with a 50% probability along with the $1,000 gamble with a 50% probability of loss. And her utility from $10,000 is equals to 10, putting it in this formula. UI equals to root 10i. Now her expected utility is equals to 0.5 into 90 to the power 0.5 plus 0.5 into 110 to the power 0.5, This comes to 9.987, which is less than his utility. Since expected utility is less than the utility gained from his wealth of $10,000, she would be risk averse, as she would not take up the gamble of losing $1,000. Now in the next question we see that Natasha is currently earning an income of $40,000 and can earn that income with surety next year. Now she is offered a chance to take a new job with a probability of 0.6 of earning 44,000 and a 0.4 probability of earning 33,000. What do you think? Should she take the new job? Let's figure it out. The utility of her current job paying 40,000 is 400 to the power 0.5, which comes to 20. Now the expected utility of the new job can be figured out, which is equals to 0.6 to the into 440 to the power 0.5 plus 0.4 into 330 to the power 0.5, which is equals to 19.85. That is less than 20. Thus again we see that the expected utility is less than the utility of wealth, and therefore she will not take the new job. One final question to this problem. In B, which was the previous question, where she would be chosen whether to take a new job or not, Natasha will be buying an insurance to protect against the variability in his income associated with that new job. If so, now we have to figure out how much she will be willing to pay for that insurance. From the previous question, we know that the utility of gamble is equals to 19.85. Now assuming that she takes the new job, Natasha would be willing to risk a premium equal to difference between the 40,000 that she was receiving previously and the utility of gamble, so as to ensure that she obtains a level of utility which is equals to 20. Now substituting this value of 19.85 into her utility function, we figure out I, which is equals to 39,410. Thus Natasha would be willing to pay for insurance equal to the risk premium, which is the difference between 40,000 minus 39,410, that is $590. Moving on to the next question. Suppose that two investments have the same three payoffs, but the probability associated with each payoff differs, as illustrated in the table given below. Now we have to find the expected return and the standard deviation of each investment. Now the expected value of investment A is equals to 0.1 into 300 plus 0.8 into 250 plus 0.1 into 200. This equals to $250. Now the variance sigma square is equals to similarly 0.1 into 300 minus 250 whole square plus 0.8 into 250 minus 250 whole square plus 0.1 into 200 minus 250 whole square. This amounts to $500. Similarly, the expected value of B equals 0.3 into 300 plus 0.4 into 250 plus 0.3 into 200, which amounts to same to $50. Similarly, we do it .3 into 300 minus 250 whole square plus 0.4 into 250 minus 250 whole square plus 0.1 into 200 minus 250 whole square, which amounts to $1,500. Now in the next question we see Jill has a utility function of u equals to 5i, where I denotes the payoff. Which investment will she choose? Jill's expected utility from investment A is EUA equals to .1 into 5 into 300 plus 0.8 into 5 into 250 plus 0.1 and 5 into 200. Remember, here we have a utility function u equals to 5i, and taking I from the table we put in out here, and calculating this we find EU equals to 1250. Similarly, we calculate for investment B. EU B equals to 0.3 into 5 into 300 plus 0.4 into 5 into 250 plus 0.3 into 5 into 300. On calculation, we find it that it is equal to the previous one, which is 1250. Since both the investment given to Jill have the same expected utility, she will be indifferent between investment A and investment B. Another example, Kane has a utility function u equals to root 5i. Which investment will he choose? Proceeding in the similar manner, we do 0.1 into 5 into 300 to the power half plus 0.8 into 5 into 250 to the power half plus 0.1 into 5 into 200 to the power half, amounting to 35.32. Similarly, we calculate EU for B, which amounts to 35.25. Notice carefully, here Kane will invest in A as it is higher slightly from B, as 35.32 is the expected utility of A, whereas 35.25 is the expected utility of B. Notice here Kane is a risk averse. Kane will always prefer investment with less variability, which in this case is investment A. In the next case, the individual has the utility function as u equals to 5i square. Similarly, we will calculate expected utility of A, expected utility of B, and then figure out which investment she will choose, which is equals to 0.1 into 5 into 300 into 300, 0.8, 5 into 250 into 250 plus 0.1, 5 into 200 into 200, amounting to 3,15,000. Similarly, for B, we see that 0.3 into 5 into 300 square plus 0.8 into 5 into 250 square plus 0.1 into 5 into 200 square, amounting to 3,20,000. Now notice investment B has a higher expected utility for the individual. Thus, she will always choose investment B.